Welcome to the gopaddle DevStar session. In today's session, we'll be covering an interesting topic of provisioning and managing elastic storage on AWS EKS cluster. One of the challenges in the cloud native space today is to automate storage management. gopaddle has partnered with Storidge, a cloud native storage provider, to ease the management of highly available persistent storage on Kubernetes. Storidge automates storage as infrastructure as code, thus minimizing the operator decisions while maximizing the operational workflow. It offers automatic failover and data recovery and keeps critical databases and applications up and running all the time. It offers consistent application performance by offering a near local storage performance. Now, why do we use gopaddle in order to provision storage on EKS? Now, as we know, gopaddle offers a centralized cluster management solution for provisioning Kubernetes across AWS, Google, or Azure. In case of EKS cluster, we can provision different types of node pools from a single console. Also, when the node pool, that is the compute scales up, the underlying storage layer automatically scales up. And lastly, gopaddle offers a few add-ons that will help you in order to do debugging or monitoring. Now let's take a look at the steps that are required in order to create an EKS cluster. We need to create a few IAM policies from AWS console. We need 3 different types of policies for 3 different types of node pools. Then we create an IAM user and assign these policies to this IAM user. From the gopaddle console, we'll register the cloud account using the IAM credentials and create an EKS cluster with 3 different types of node pools. A managed node pool is automatically created by EKS, a custom pool uses a custom AMI, and storage pool uses a custom AMI along with storage as the underlying storage management solution. Once the cluster is up and running, we need a storage provisioner which uses CIO as the underlying storage driver. Then we launch an application on this cluster and set the node affinity to launch the stateful sets on the storage node pool. Once the application is up and running, we are going to access this application using a domain name. We can check the different types of policies that are available from the help document. So in this section, we can see there are 3 different policies, one for custom AMI and one for storage node pool. And now let's copy the general policy here and then navigate to the AWS console and create an IAM policy for the general access. Let's copy the IAM policies for creating a custom node pool and then create the second policy. Now let's copy the third set of policies for creating a storage node pool. Depending upon what types of node pools are required, we can selectively create these policies and then assign those to the IAM user. Now let's create an IAM user and provide a programmatic access to this user and choose the existing policies that we just created. Now copy the access key and the secret key and navigate to the gopaddle portal. Under the infrastructure cloud account section, we can register this cloud account using the credentials that we just now copied. Using this cloud account, we are going to create an EKS cluster in the AP Southeast 1 region, and we'll provide the cidr ranges for the VPC. We also require a role to be created for the cluster master. So clicking on the create option there would take us to the AWS console where we can review the role YAML file and create an role here. Once the role is created, the ARN will be available under the output section. copy the ARN and then provide it here. And we'll create a manage node pool. And for each node pool, we need to create a new role as well. Let's copy the ARN again and provide it here. And let's create the cluster. So the cluster is in running state now. And we can see there are 3 subnets and a VPC is automatically created. Let's check the node information, and we can see that it has been labeled automatically as the managed pool. We can also see the config file which we can use in order to access the cluster using kubectl commands. Now let's create a custom pool and provide a custom AMI, and let's create one more role for the node pool. Now this creation may take a while, maybe about 5-10 minutes. And once the node pool is created, it moves to running state and it's ready for scheduling workloads. So we can see it's using a custom AMI and it's running on EBS volumes. Let's create a storage node pool, and once we enable the storage option, we can see the custom AMI is also required, and the minimum number of nodes required are 3, and we'll set the disk size to 100 GB. Let's create another role for storage pool. This time the rules are slightly different from the other node pool role. So we'll be creating a few rules for SSM documents. And let's create the storage pool. And storage pool creation also might take a while, maybe about 15-20 minutes. Once the storage pool is moved to running state, we can see that there are 3 nodes, and the nodes are ready to be scheduled only if these labels are set. We can also review the different stack logs here. We have a node pool stack, VPC stack log, and we can also see the auto-scaling group logs as well. In case of storage pool, we can also review the SSM document logs. Now let's check the storage provisioner. So I've already created a storage policy that uses the CIO as the underlying driver, and there is a domain that is already registered. Let's choose one of the deployment templates. So I have a pet clinic application. Let's launch this on the EKS cluster and use Storidge as the policy. And we need to set the node selector. Let's choose the storage node pool and then launch the application. While the application is still in creating state, we can check the activity logs here. So this is going to install a few add-ons in the cluster for the first time. So this is used for monitoring the application. So we have two services, and MySQL is using the storage provisioner. So it has one replica and it is in running state. Let's check the volumes. We have one data volume and it's in running state and it is bound to a pod. Let's check the volume timeline to see the monitoring of the volume. We can see the IOPS capacity and the sectors that are being utilized. So we can assign this endpoint location to the pet clinic domain in our domain name provider, and once that is assigned, we can access the application using the domain name. Let's go to the cluster and we can see the add-ons that are installed. So we have a Grafana add-on that is automatically installed when an application is deployed in the cluster. So we can apply a few templates to see the different infrastructure monitoring. And we can also see the storage monitoring as well. Okay, now let's import the storage template. So we can get the different resource utilization metrics around the storage capacity. Okay, we can also see that it has installed a CIO prom as an add-on in the cluster. Now this brings us to the end of the session. Hope you found this session useful. I'm really eager to hearing back from you on your feedback on how it helped you in managing storage on EKS. Thank you very much.